Here's example 2 of experimental and theoretical probability. There are 25 total students in a study hall. The table shows the number of students who are studying a foreign language. What is the probability that a randomly selected student is not in a foreign language? So what we want to do is we want to add up the total of students that are studying a foreign language, so 6, 12, and 13, which is 21. So these are all the students that are studying for a language. So I'm just going to go ahead and probability of a foreign language. So that's 21 out of 25 that are. So how many are not studying a foreign language? So we could either use the complement rule and just subtract 1 minus 21 25ths, or count up how many students that are not in the foreign language, which is 4 out of 25. Example 3. Two integers from 1 to 10 are selected. The same number may be chosen twice. What is the probability that both of the numbers are less than 9? So we'll just go ahead and write down the sample space. And then we want the numbers to be less than 9. So this is the favorable outcomes, so 1 through 8. So we'd say the probability of the first number to be less than 9 and the second number to be less than 9. What you would do is you'd multiply the favorable outcomes, 8 out of 10, and then the second event, 8 out of 10. Then you multiply across, 64 out of 100, and then simplify it, 16 25ths. Example 4. You roll a dice 4 times, and the results are 1, 3, 6, and 5. What is the probability of a prime number? So prime numbers in a dice are 1, 3, 5, 7, 11, 13, 17, etc. And what we want to do is figure out which one of those in the sample space is a prime number. So in the sample space that we got, 1, 3, 6, and 5, 1, 3, and 5 are prime numbers, so that's our successive. So 1, 3, and 5 are favorable, and the one that's not favorable is 6. So prime number is 3 out of 4. James has hatched 36 chickens on his farm. Of the 36 chickens, 9 have been boys. What is the probability of a boy chicken being picked? So there were 36 total chickens, and the favorable outcomes are 9. So 9 out of 36. or we can reduce that to 1/4. A spinner has 7 sections labeled 1 through 7. So 1, 2, 3, 4, 5, 6, 7. And then there's a spinner in the middle, and it goes around and spins. What is the probability that a 5 is spun? So the sample space is 1 through 7, so there's 7 possibilities. And the successful outcome is 5. So there's one number 5. And this is a theoretical probability.